So let's assume for the sake of argument that you ran a series of CFD runs to try to predict the performance of a UAV vehicle. And you go through, in principle, how you typically would evaluate these data would be by bringing in the solutions, setting up your default views, and perhaps trying to identify an area of interest, like looking at the pressure coming off the wing. And then you would try to apply this strategy to all the results that you have. In Chorus, you can bring all those results into a database, and you can see we can view the data here. And we can actually start with a view. Now you can see that we're actually looking at a view of that same cut on the wing. And we can bring that cut in or look at several of these data files. So if I wanted to look at a different run, in this case, a higher Mach number, you can go in now and look at that, or even bring in two Mach numbers, evaluate what the net differences are visually. Or if I want to, I can actually look at this more quantifiable as well. I can go in and look at an actual delta. If I like the view, I can also save it as a template, and we'll call this T3. So the idea here being that you want to be able to set up default views. So if we view the data here for the third template, and we'll pop back into the visualizer, you can see this is for the higher Mach number, this is for the lower Mach number. That's for the original case. And this is the two cases we were looking at just a second ago. And again, if I want to, I can look at a quantified difference. So now you're looking at a delta, and this is actually a quantitative delta. So that's an easy way to evaluate, say, one or two solutions. But when you're looking at 30, you want to take a look at something like a matrix view, where we're now evaluating all the Mach number, or all the Mach, or alpha equals 0, and all the different Mach numbers that we looked at. And we'll actually apply some labels here that will help us understand what's going on. And then we'll apply a delta to that, and so we can look at a pixel difference between low and high Mach numbers. So we have our original images, you can see, as well as our table, and they're all linked together, so it gives you a quick way to understand what's changing. Another thing we might want to do is use our tool to generate some new images based on our T3 paradigm. So we have a new template that we brought in, and we can set that up to run. We'll also just take a look at, say, a quick view of the derived quantities and apply a simple quadratic response surface to the fit of the data of drag. And so if we turn this on, you can see now we're looking at system performance by using a simplified response surface. And you can see the job is done. We can deposit those into our database, so we're actually building out additional plots. So now if you take a look here, we have that delta. In the same image, we actually have our images, and you can see that we have some of those with this new T3, which was our second template, is T2. So you can really start to build out a project that allows you to analyze what's going on within a system. So in addition to that flexibility, you also have the ability to, in effect, filter the data. So if you only want to look at low Mach numbers, you can use a filter there. Another thing you can do is take a look at the data as a series of line plots. We'll use Mach versus drag, and we'll go ahead and look at these as a function of alpha. And we'll take advantage of the fact that we can use a single value filter and just look at the beta equals 0. And you can see now, based on that simple quadratic response surface, you get a sense of how the data fit for my different alpha values, so for alpha 0. And if I go to just a single value, I can now walk through each one of my alpha curves and get a sense very quickly on how the system is performing, how the system is responding to those conditions. So we've talked a little bit about how one can actually look at just images or plots. We've talked about what you can do with what we'll call this matrix view. But this is a way that you can quickly evaluate whole systems of simulation in a very quick way. In addition, I can create additional data or look at additional data, like in this case. We'll go ahead and bring in a bunch of solutions, and because we can look at just surface quantities, we can bring those data into TechPlot 360, which is the visualizer in this case. So we're actually looking at, as you can see, about 12 solutions simultaneously. Now I'm just going to quickly change the view here so that we look at them in a tiled environment. And remember, you can see down at the bottom we're also looking at a delta as well, but I'll quickly look at these in more of an array. and we can try to fit these to the screen so it's a little easier to see. We're working on making this process a little faster, but you can see now that we're actually looking at all the results because we're looking at surface quantities from TechBlock Chorus. You can then get a sense of how the system is changing and behaving.